Alright, in our last video, we introduced electron configuration. We did it with a little, kind of a little trick called the Electron Hotel. We don't need the Electron Hotel, and I need to wean you away from the Electron Hotel because we have something much better called the periodic table. The periodic table, you might not have noticed before, but hopefully you do now, is actually organized like the Electron Hotel. If you remember, the s orbital had 2 electrons, the p orbital had 6 electrons, the d orbital had 10, and the f had 14. And that's the way the periodic table here is also organized. Now, we have helium over here, and we're going to, for this, and it is a noble gas, but for right now, we're going to kind of just delete it out there, and we'll put it over here instead. There's our helium. So it would be a 1s also. So you'll notice that the first 2 columns, this tower here, is the what we'll call the S block. And then over here we got this nice square block called the P block, and you'll notice that there's 6 electrons across that. 2 across the S and 6 across the P. And then in the middle section, and we can go ahead and kind of extend this out there, and we could actually put another section here. This would be the 7P. This would be the 6D. This middle section here, what we call the transition elements, there's 10. There's 10 across. And then the F's down here below, all the way across, if you count the elements across, there's 14. See, it fits out perfectly. Okay, now what you should notice here is that the period numbers, 1, 2, 3, 4, 5, 6, and 7, when you're in the S's or the P's, which we call the representative elements, the sublevel number is the energy level number or the period number. So this in the second row I do have the 2s and the 2p's, and the sixth row I do have the 6s and the 6p's. But the d's are a little different. It's actually 1 less than the period number, and the reason, of course, is that a d is the third sublevel, and you can't have 3 sublevels till you're in the third energy level anyway. So you'll notice that we put an electron in the 4s1 and then the 4s2, and then the next electron goes in the 3d1. So the thing to remember is that the d's, the transitions here, it starts with 3d. The first d sublevel is the 3d, and then 4d, 5d, 6d, and you just need to remember that. Or you might think the d's, this d block is period number -1. So if you see it's in the 4th period, in the D block, then you'll know that that's actually 3D, not 4D. People get confused on that. The F's are technically right here. They go right into here. And so technically it's in periods 6 and 7. But you don't have an F sublevel till you get to a 4th energy level. So although this is in the 6th period, it's the 4F. So this you would think is maybe period number -2. So the inner transition elements, and I guess I would just memorize it, it's 4F and 5F. I mean, those are the 2 F sublevels that you need, 4F and 5F. So now I can just go through the electron configuration and just put them in. So I could have 1s2 and 2s2, and then 2p6 and 3s2 and 3p6, 4s2 and 3d10 and 4p6, and it's very easy to do electron configuration this way if you can understand how the periodic table is arranged. 5s2, 4d10, 5p6, 6s2, then don't forget 4f14, 5d10, 6p6, 7s2, 5f14, 6d10, if we went all the way over there, 7p6, and so on. So this is very easy because sometimes what I might do is I might say, what is the ending configuration for a certain element? And on here it doesn't actually have the elements, but I could say, okay, like right here, this is technically magnesium on the periodic table. If I said, what's magnesium's ending configuration? Well, it'd be 3s2. That'd be 3s2. What about this element right here? Well, that'd be 5s1. 5s1. What about this element right here? Okay, I mean, and you'd have to see where it is in the periodic table. This is silver, right? It'd be 4d9. 4d9. This element right here would be 4p5. 4p5. This element right here would be 5F13. That would be the ending configuration for a particular element. And that might be something I'd ask. What is the ending configuration? So you have to just see where the element is on the periodic table, and you have to know that you have an S block, a P block, a D block, and an F block. And just know that the D block starts with 3D and the F block starts with 4F. And hopefully that will help. Okay, so if we look at this again here, and let's say I want to find the electron configuration for Mercury, which is one that we've already done, and Mercury happens to be right here. So let's see if we can do it a little easier without the electron hotel. Okay, so I start at the top, and remember helium is going to be over here, 1s. This is a 1s, so we won't put it there. So if I just start here at the top, you'd have 1s2, and then this 2s2, these 2p6, 3s2, 3p6, 4s2, 3d10, 4p6, and you're going to want to do this with a periodic table, not just with this thing. This thing is probably pretty easy, but the periodic table, it might be a little harder to remember where these are. 5s2, 4d10, 5p6, 6s2, and then where do we go? Yep, down here. 4f14, and back up to here all the way to Mercury. I ran out of room. 5d10. If I was going just to gold, which is right here, I would have just ended with 5d9 instead. So that's the electron configuration for Mercury, and that's how we can use the periodic table to easily do it. We do not need an electron hotel. You can just look at your periodic table and go from the top until what you need to get to. Okay, hopefully that makes a little sense. Okay, so one shortcut, because that's the long configuration. So there is a shortcut that you can write an abbreviated electron configuration. Let's say that we want to write the configuration, we'll say for, let's do this one right there. So that'd be Lawrencium, element number 103. Okay, 103. I'm going to write the electron configuration for this. Okay. All you need to do if you want to write the abbreviated electron configuration is just start the electron or the element that you want to finish on, and go back to the last noble gas before that element. So the last noble gas before that element was right here, which happens to be radon, Rn, radon. So what you can do instead is just go ahead and write in square brackets the element symbol, radon, okay? And that will actually represent the electron configuration all the way up to radon. I know, it's pretty nice. Okay, that means a lot less writing. So I can write the electron configuration all the way up to radon, or I can just have it be represented by this, which is what I'm going to do. But then I have to go on from there. So after radon, we have 7s2, and then remember, we got to drop down to here, get these, 5f14, and then up here in the 6d, we just need 1, so 6d1. That'd be the abbreviated electron configuration for 103. I wouldn't have to write out all this stuff. So that's pretty nice. Let's practice that one more time. Let's do this one right here. So that'd be astatine. Okay, the last noble gas would be this one right here, and that'd be xenon. So you would write down in square brackets Xe, and then we'd go on from there. 6s2, and then remember, after there, comes down here, so we'd have 4f14, and then 5d10, and then 6p, 1, 2, 3, 4, 5. 6p5. That would be the abbreviated electron configuration for the element astatine, which is AT. Astatine. Okay, so if you want to write the abbreviated, so on the competency, I would ask, there's several questions I would ask. I would ask you to write out the long electron configuration for an element. I'd ask you maybe to write the abbreviated electron configuration where you start with a noble gas. Or I might ask you just what's the ending. So I'd say, what's the ending for astatine? You'd write 6p5. That'd probably be the easiest thing to do. By the way, you cannot start the abbreviated thing until you are past neon. So if I was trying to write the abbreviated electron configuration for neon, I couldn't just go back and start with, He, and then, 2s2, 2p6. Okay? There's no, I'm not wasting any time. I'm just, instead of helium, you would just write 1s2, and that's just as easy. So you can't do it until you get past neon. And if you're trying to find the noble gas, you can't just write down the noble gas in brackets. So if I want to find the electron configuration for this one right here, which is argon, I can't just write down argon. I'd have to write down neon, Ne, the last noble gas, and then I'd go on from there. So it'd be 3s2, 3p6 would be argon. I'd have to go the last noble gas even if I'm on a current noble gas. So that's how you do the electron configuration, the abbreviated electron configuration. Hopefully that makes sense. If not, I would probably watch these videos again.